Hello and welcome to this webcast, Optimize Your HPC Storage Strategy. This webcast is hosted by Scientific Computing World and sponsored by Seagate. My name is Robert Rowe. I'm the editor of Scientific Computing World, and our guest panelists today are Andy Palmer, Enterprise Data and Cloud Solutions Group UK Channel Lead at Seagate, Mark Nozakoff, Research Director at Hyperion Research. Unfortunately, he's just having a few technical difficulties. We'll try and get him connected as soon as possible. And Deepak Agarwal, who is the Principal HPC Systems Manager at the University of Cambridge. With 35 years in the high-tech industry, Andy Palmer brings expertise in advanced semiconductors, data center infrastructure, auto ID, and data storage. As a specialist in both cloud and physical data movement, Andy helps organizations optimize how data flows from endpoint to cloud. His insights are especially relevant for pharma research teams navigating complex IT environments. Mark Nozakoff is a research director at Hyperion Research, an industry analyst and market research firm specializing in HPC and AI markets. Mark's area of focus include data platforms, storage systems, system interconnects, and cloud utilization, along with general market trend analysis, business planning, and technology ecosystem activities. Deepak Agarwal is the principal HPC systems manager, where he works in the design and operation of advanced HPC and AI platforms that support cutting-edge research. His work focuses on bridging the gap between researchers and research computing infrastructure, enabling more effective use of large-scale systems, storage, and cloud resources. Thank you to each of our speakers for joining us today. Now, on to the topic of today's discussion. HPC is driving breakthroughs in scientific research, from climate modeling to genomics, particle physics, and AI simulations. However, these massive data volumes generated by these applications demand robust, scalable, and high-speed storage solutions. Efficient storage architectures are essential for accelerating data access, ensuring reliability, and optimizing computational workflows. This online panel discussion aims to explore the landscape of data storage, including its challenges, AI-driven data processing, sustainability, and resource constraints. After the discussion, there will be a question and answer session, which anyone can use to ask our speakers a question. If we do not have time to answer your question today, the information will be passed along to the relevant people so they can follow up at a later date. So don't worry if we don't have time today. So without further ado, the first questions for our panelists. Could you briefly introduce your background and current involvement with HPC or scientific data storage? Andy, could you potentially start us off here?
Yeah, for sure. Thank you for the introduction. So my name is Andy Palmer, as you know, and I've been with Seagate for about 13 years now. Formerly selling our best known product, which is the hard drive business, but latterly selling Seagate systems, cloud services, and data transfer as a service. And the markets we do very well in, we serve best are among many, but it's to do with video image analysis and scientific research, and we're very aligned to a lot of organizations around Europe, the universities and the research agencies that serve some of the big pharma companies, helping them design and architect data storage strategies, and also aligning infrastructure with research goals and workflows and that sort of thing. And then most recently, how do we get ready for AI as that AI wave comes and drives more and more data storage?
And Deepak.
Yep, thank you. Hi, myself Deepak Agrawal, Principal HPC Systems Manager at the University of Cambridge. I lead the storage team within the Research Computing Services at the University of Cambridge. I work closely on the UK government's AI Research Resource Project program called AIR. We have a system which is one of the biggest AI system in UK called Dawn. It has more than 1,000 Intel GPUs, one of a kind. GPUs in the system, and they're being used for the AI research within UK. And if I summarize my role, I sit at the intersection of HPC data and the people who are using it, turning complex systems into meaningful outcomes. I started my professional journey roughly 15 years back in physics, working in nuclear fusion research as a nuclear analyst for about 5 years before transitioning into the high performance computing services team. I've seen, the transition of workload from HPC, traditional HPC workloads to the AI workload, and how the requirement of storage has, kind of evolved based on this transition. And I'm looking forward to the discussion, in this panel. Thanks.
So on that point, this is a bit of a simplification, but during that transition from kind of HPC to AI, the demand for data and research has kind of exploded. From your perspective, what's driving this surge, and how does it reshape storage strategies? Deepak, would you mind taking this one first?
Yeah, no. I think that the data search is being driven by science itself. If I can summarize in a single sentence, there are big scientific projects going around. It could be the one on nuclear fusion, which is ITER. The other one is the SK, Square Kilometer Array, in astronomy. They are all generating big data in terabytes and maybe in petabytes in some of the experiments. The thing is, they need access to that data. With every simulation, they don't have to kind of do all the simulation every time they need access to the data. So the storage of the big data is kind of a issue in terms of reproducibility. At Cambridge, this reality has fundamentally changed how we build and operate our infrastructure. So every architecture choice that we have taken, from the network topology to the system design and even, the power provisioning of the system is now data driven. We have evolved from a monolithic, storage tier system to an interconnected life cycle aware ecosystem. So we have fast lecture for the data which needs to be closer to the compute infrastructure. We have resilient storage for critical data asset, and then we have tape system for long-term data retention. So these tiers, they don't stand alone. They talk to each other. And so yeah, I would say storage is like the oxygen for compute infrastructure in nowadays.
Absolutely. Andy, what are your thoughts on this?
Well, for sure, data creation is growing. Not long ago, we were saying that the amount of data being created would be 175 zettabytes, and we've recently changed that narrative to actually be 400 zettabytes. Most of the growth is actually from AI. And how it affects data architecture is the reason why it's growing so quickly is because the nature of data is changing from nice, neat text and data files to what we call unstructured data, which is text, audio, images, video, sensor logs, that sort of thing. And it's that kind of data which is much bigger than traditional, text files, nice, neat rows of figures and things. And then on top of that, you've got this whole cycle of data, which is, data driving insights driving actions getting decisions getting results, and the results go back into the pool of data. And so it's that cycle of data which is getting faster and faster and driving a lot of data growth. And then what that means in terms of how we architect that, it needs, Deepak mentioned there about collaboration and more of a multi-tiered structured approach, and that's very much a common architecture across a lot of industries that we work with. But really, it's about how do you manage the trade-offs between what you can afford and what you need in terms of performance, what kind of data you're storing, keeping it secure, of course, and managing the trade-off between security and availability to the right user at the right time, and planning a course for future growth, which is essential to avoid bottlenecks in the future. So it's an evolving landscape, sure, and one fueled by growth, absolutely.
And Mark, thank you for joining us. Apologies, I know you've had some technical difficulties.
No worries. Great. I apologize for my side too. So great to be here. Thanks for having me.
Quite all right. Yeah. So yeah, we were just talking about the kind of the growth for in demand for data and research. From your perspective, you know, what's driving this surge, and how is it reshaping storage strategies in HPC?
Well, what's driving it is a number of things. You probably already touched on it. But so you have the traditional scientific and engineering workloads that typically had been, you know, for modeling and simulation. There's higher resolution of the data, more data inputs coming in from various different sensors and other ingest areas. Then add AI on top of that, and it's just all of the additional training data being brought in, and it's not just the capacity of the data, the amount of the data, but it's, you know, different types and different access methods that it's being used differently. You've got both large block and large block. You've got more heterogeneous reads and writes, and maybe traditional writes and other more traditional HPC mod sim applications. And so with the diversity of the workloads being demanding of the data, are driving different architectures of the storage systems to be able to handle a more diverse data stream and data pipeline than before.
Absolutely, and kind of on a similar note, you know, what strategies can researchers or service providers use to handle large-scale data sets? I mean, that's one of the things that I guess you've all touched on to a certain extent is that kind of data sets are getting larger. Mark, could you kick us off on this one, please?
Yeah, so for the strategies is just being able to look at and understand of the data where it's needed and get it where it's needed and when it's needed, and for the understand the solutions, not just from the storage providers, but the overall system capabilities. Is it GPU driven and accelerated types of workloads that are demanding the data, and so the need then to ensure that the solutions and data platforms are capable of providing the bandwidth and getting the data where it's needed when it's needed for the type of workloads and activity.
And Deepak, what are your thoughts on this?
I think I agree with what Mark said. The idea is quite simple here. The data should move to the right tier at the right time, and it should be accessible, you know, with the kind of performance that the users need. I feel, you know, from the university's point of view, the large scale data sets efficiently is this isn't just about the capacity. As I said earlier, we have you know, a tiered system for the storage as a service within the university, and the idea is to, you know, provide the users the storage tier that they need. If they need it for performance, there's, you know, a different model. If they need it for long-term storage, there's a different model. And each one of the model, you know, it has some cost implications. You know, there's a huge difference if you're buying a high performance storage for 1 year as compared to buying the same amount of storage in a tape library. So yeah, the awareness about the needs from the researchers is very much needed. What kind of data sets they are bringing in onto the system. So a recent example that I can give that we have implemented on the Dawn AI system is using the NVMe based Lustre file system for making the AI workloads, you know, faster. So the idea is to use this NVMe based is slash file system as a transient storage for the workloads when they are running on those GPUs, and integrating this with the Slurm scheduling layer, so no data will live on this system permanently. Users can just burst into it when they are running their jobs and flush the results to their storage area when the jobs are finished. So yeah, that's what I feel is needed. But yeah.
And Andy, it's always the most difficult to go last in these situations, but do you have anything you'd like to add?
Yeah, but I get the advantage of hearing what they said first.
Yeah,
right?
yeah, that's true.
And everything that was said, that two speakers have said, it is absolutely spot on. The only thing I would say is that if you think about, if you will, the history of an organization's data is grown organically, and on average, organizations have around 10 data silos. And you think about what that is, that's 10 lumps of data unconnected to anything else. It's often repeated. It's not optimized for AI tools and that sort of thing. So I think that the first strategy should be to make sure your data is in order, that you know where it is, because Department A has got it on a NAS system, Department B has got it on a mainframe, Department C has got it on a few mobile hard drives. Where is that data? Get it all under a single pane of glass, and then look for the duplications, look for the errors, and there are various software tools available to do that. Only once you've taken those steps and your data is as clean and as efficient as it's going to be, you can then expect it to be high performance data. And then all the talk about moving it to the right place at the right time is absolutely critical. Tiered storage is what Deepak was alluding to. I mentioned it in one of my last answers about selecting the right performance tier or the right data for the right performance tier. And it's not all one level. Data calls. I think the stat is that only 10% of all data is actually in use at any one time, and therefore could need the IOPS performance afforded by an NVMe layer, for example. And then managing the data lifecycle. What can you automate? What policies can you insert into the system to move data as it cools and changes in importance? All these things are tools that are available and offered as part of a package of a larger data center management approach. And we're very much about get the data right in the first place, storing it efficiently, keeping it safe, and then making it available.
Okay, and the next question I had was about I/O performance, and how can you improve I/O performance as data continues to grow? Is this just as simple as making sure it's in the right tier, or is there kind of more to go on that? Deepak, would you mind starting us off there?
Yeah, I think for me, if you're looking at the I/O performance, the locality is critical, as critical as the flops are in in the HPC world. And we have learned that a well-placed cache or metadata server can do more for the users than adding more disks to the storage system. And just to give you some numbers, the NVMe file system that we implemented on Dawn, we achieved somewhere around 85 GBs of write and 92 GBs of read per node on a single node system. These results are very critical for the AI intensive workloads that these systems are being used for. Typical, the storage, if you talk about typical, storage, which is more common in the HPC systems, it could be one of the performance, lag for the AI workloads. So having the locality, having the storage as close as possible to the compute gives more freedom, to get the performance out of the AI workloads.
And sorry, Andy, what's your thoughts on that?
Actually, very similar. What Deepak's saying is that it's the proximity to the compute function of data to avoid latency is vitally important to improve IO performance. And then we have the tiered storage I mentioned earlier with NVMe or SSD that supports very demanding workloads. And then it's about sustained data at scale, which is I think where Seagate's sweet spot is. How do you manage it sort of petabyte level and keeping that available? And I think that's where we specialize. And then I think as well, architecting for concurrent access and multi-user environments is really important as well. But parallel file systems and proximity, as well as the trade-off between the performance tier and the capacity tier, those are the things that are going to optimize IO performance.
And Mark, do you have anything you'd like to add on this topic?
Yeah, I know we've been talking about, proximity is certainly key. The best I/O is one that you don't even have to do. So we've been talking about data movement. So if there's any possibilities and any way to architect it such that the movement of the data is minimized. Now, in many cases, that's just not possible. There is going to be some movement in certain cases, but if there's a way to, when you're laying out the system and architecting it, and the data flows, knowing where things are going to be when you want them, if you can, just kind of minimize the data movement. That's ideal. Then ultimately, too, it's the overall system performance. Yes, I/O performance, but then the proper matching of performance between the compute, the networking, and the storage. So we're talking about the storage itself, but the interconnect and the networking technology is critically important too, such that you've got the right balance between compute. Networking and storage is kind of a whack-a-mole game. You might improve performance on one, but then the bottleneck moves and the mole pops up somewhere else, and you got to go hit that one on the head to get it back in alignment.
Absolutely. Now, obviously, the easiest way to solve some of these problems is to buy the latest and greatest technologies. But many research groups operate under tight budgets. How do cost constraints affect decisions about storage and architecture and scalability? Mark, would you take this one for us first?
Yeah, it is critical. When we look at our market research data, if we're first looking at the on-premises types of systems, compute takes up roughly over 50% of an overall budget in general, and then storage is anywhere around low to 20% of budgets. And with the price and cost of these of the compute going up, that's really impacting what's available for the other parts of the system. So I think that presents an even a greater burden and challenge for funds and budget available for storage. So it's critically important then that it is factored in up front and is not an afterthought. That if the rest of the system is getting all the attention, both money-wise and mindshare-wise and architecture, and the storage is just an afterthought, then there's going to be issues and challenges. So understanding it from the front up front. Ideally, it's an architecture too that you could identify that can easily scale, that you don't need to buy a lot. You don't have to over provision up front just to buy capacity and or performance that you think you might need in the future. A scalable type solution that you can easily upgrade and migrate and make extensible in the future, I think can help with the budget concerns.
And Deepak, do you have any additional thoughts on this? I guess Cambridge has a slightly different model maybe than some other research centers.
Yeah, from the university's context, I think it's a really good question, considering the research computing within the universities, they are trying to sustain the on-premise setups, and cost isn't just a factor, is actually the main design constraint for the universities. Fortunately, at Cambridge, we learned that long back, and that's the reason we have this tiered, storage system for the users, which has a very different, cost model for different services that we use. Just to give, a quantitative example here. So, like the high performance storage system for 1 petabyte, it would cost like £54 per year for our users. And if they need 1 terabyte I mean the same amount of storage in the tape library, it would be half the cost. So I think, as Mark said, developing these solutions as based on the need to be, using the budgets that we have optimally is one of the design factors. So that's why this 3-tier system exists at the University of Cambridge, and it's being used very well. So there are enough use cases for all the storage services that we have, and it's sustainable in that sense, because if there's a group of there's a research group, they need large amount of storage, but that's not something they need on a high performance system. So they could go for a solution which is half the cost of the high performance storage system. So this is working well for us.
And Andy, do you have anything you'd like to add?
Yeah, I agree with Mark that modular systems are the way forward, so that you can grow them incrementally. And I'm thinking about customers who buy a chassis from us that's partially populated, and they can just add on extra hard drives as their requirements and budget allows. That's just one aspect of it, but that's still to do with the acquisition cost. There's also the ownership costs around, power, for the energy required to run the system and to cool the system down, and the overheads around space and this sort of thing. And so looking at high capacity hard drives allows you to get into high density systems, so you utilize space a lot better, and power and cooling is much more efficient. And then of course, what functionality is native to the storage. For example, we have the ability to halve the CPU and RAM costs of the compute layer, normally dedicated to managing storage. Well, if that can be done natively inside the storage enclosure without any recourse back to the compute layer, then it's possible to save a lot of money, a lot of money there. So it's not just about acquisition costs, it's about TCO costs as well for us. But certainly that modularity, that eye to the future, what will I need now, what will I need in 5 years time, and build that capability into the architecture is, I think, where Seagate's expertise certainly lies.
Okay, and do you see challenges in how cloud, hybrid, and on-premise solutions coexist in current HPC environments? Andy, could you start us off, please?
Certainly, the more layers you have, the more complex it becomes. Just touching back on the topic of the last question about cost and things, one of the critical factors is that the cloud costs has to be predictable. And one of the big complaints that I get when I talk to my customers is, like the idea of cloud and the elasticity of cloud, but none of us know how much it's going to cost. And in this day of budget constraints, we need to be absolutely predictable and hit our cost forecasts. So when you move to a hybrid, you've got the on-prem, which I guess you bought or you're leasing for a fixed fee. You then got the multi-cloud environment that most people tend to use because they use the resources of different cloud providers. We always say that you date your compute network, but you marry your storage. And so it's really important to marry well and marry for the long term. So I think that adding on layers makes it more complicated. What you can do to reduce that complication is to make it all predictable and as transparent and interoperable as possible. And again, I think that we've got some very good technologies around that answer some of those questions.
And Mark, what are your thoughts on this topic?
Yeah, that some of the in our market research, when we see who's going to the cloud, what are drivers for why people use the cloud, and what are barriers, the cost aspect of it. Actually, the cost appears as both a driver, because in some cases users actually see cost benefits, but more often than not, it's the unpredictability or perceived lack of transparency for what the cost might be. But there are still times when the cloud can be beneficial for particular workloads that need the most advanced technology, compute capability that you just don't have on-prem yet. So the architecture and ability should exist such that you can have the data available both on-prem and accessible in the cloud in a seamless, transparent, non-disruptive way. The other notion too is that having the same operating environment. Another hurdle that we hear and barrier that we hear is codes that are written on-prem. It's difficulty and could have take some effort to make it cloud friendly or cloud ready. So if as researchers, their workloads and their applications are able to run in the cloud and on-prem, and if Lustre was mentioned before, whatever CSP, they have a managed Lustre or some sort of Lustre capability that can be easily spanned and almost be seamlessly make it seamless to the researcher to whether it's going to be run on-prem or in the cloud can provide some benefits.
Okay, and Deepak, do you have any closing thoughts on this topic?
Yeah, I mean, apart from the unpredictable cost, the other challenge that I see is kind of consistency when you burst. If you have an on-premise system, and if you want to burst your capacity for even for storage or compute into the cloud, and making sure that data management, the security, the identities work the same way that they are working on your on-premise system is something which we are kind of exploring, because currently we have everything on-premise, and which gives us predictable cost, control over security, and we can tune the performance down to the hardware. But we are exploring the integration with the cloud to test our bursting need that we are having from some of the large research groups that we have in the university.
Okay, and how is that exploration going? Are you kind of limited in trying to pick cloud services which kind of loosely match the type of software and hardware that you have, or what are your experiences so far?
So I mean, the way in which we provide services, so we have a private cloud. So in terms of the flexibility that our users have, they can basically request anything and they can get the kind of experience that they'll get in any public cloud. Now, when it comes to integrating your system into a public cloud system, there are a lot of challenges, and the challenges lies in terms of how you want to present it to the users. If you want to be completely transparent and seamless for them, then it comes with some technical challenges that you have to work out with the cloud provider. And as I said, networking, identities, and controlling the cost is a big factor, because in cloud the cost of storage will look something, but based on how much interaction, ingress egress you are having, it can change drastically, and sometimes the customer may not be noticing all these changes happening.
And AI and machine learning have become, key tools in scientific discovery. Do they introduce additional challenges? Deepak, would you go first on this one, please?
Yes, they do. Not just technically, I think, but culturally too. Traditionally in HPC, we deal with, well-defined simulation workflows. We have the input, you come with a model and you run the model on these compute servers and you get the output. When it comes to, AI workload is mostly data driven rather than model driven, and this means that the data volumes, the data movement and even storage design have to evolve with this change. AI workloads, if you see, are far more demanding, as we discussed, in terms of the IO performance. They thrive on the fast, low latency access to the huge number of small files or data sets, which the traditional storage was not built for. So the second challenge I see is data management and ethics, and AI is kind of introducing new questions, be it about from where it is, the data is originating, versioning of the data, and reproducibility of the data, and how do we ensure that the data on which the model has been trained is coming from an authentic source, and how do you ensure the compliance was followed and trust when the data moves across institutions. So I mean, AI is driving, the scientific discovery, but it has its own challenges in terms of, the compliance and the trust we can have.
Yeah, that's a great point. I guess it's particularly for when you're talking about workloads that serve regulated industries, if pharma and biotech and that type of thing, or anywhere that's potentially using healthcare type data, things can get complicated quite quickly. Andy, what are your thoughts on this topic?
Yeah, just building on that point, the law, the EU AI law says that if you make a decision based on AI, you've got to keep a snapshot of the data used during that decision-making process somewhere. That just adds to the data volumes being stored. And going back to what I said earlier, that it's key that the data is prepared before the AI modeling takes place, or else you just won't get the required returns on investment that you're making with the value. An awful lot, depending on which market research report you read, upwards of 75% of AI projects don't come to fruition because they don't prepare the data well enough in advance. So there's that issue. First of all, how do you prepare your data? How do you comply with law? And then building on what Deepak said about data integrity, you need to build sandbox your own data. So I'll tell you about what Seagate does. We use Microsoft Copilot as our go-to tool in the AI world. We have two versions. One is the internal version, which is sandbox. So we use Seagate data and it's kept within Seagate. It's not available outside. And then we have the outside version of Copilot, which uses publicly available data. And you're right, you have to test the veracity of the data that you're going to build on, because if you're making critical decisions, you should have a solid base for that. And then when you come to the architecture around storage, it needs to be, rapid ingest provides the first layer. Once you've cleaned the data, get it into the GPU as fast as you can. Use the data, of course, for the modeling, and then the output needs the output metadata needs to be stored as well. So it's quite a complicated thing. And as I think it was Deepak said, traditional hardware may not be good enough anymore, and we need to rethink the tools we have and the hardware that we deploy.
And Mark, what are your thoughts on this topic?
Yeah, a number of things were touched on. I mentioned some earlier, and first starting with the traditional HPC modeling, simulating and modeling, and in large part the I/O and the storage was based on what drove the requirements there were the checkpoint writes, checkpoint restarts, that require the large block, high bandwidth, sequential, mostly writes. where the AI workloads are just introducing diversity across that. It's not just sequential, it's a lot of random small files instead of large single files or small numbers of files. It's more read-write and not just write. So that's places different requirements on the storage system. The notion too of the compliance. Not just I had a conversation with a guy who ran the software, the compute environment of one of the major insurance companies within the United States. And within the United States, insurance isn't nationally regulated, or not national compliance. It's by each state, and may have their own different ones. So even within the United States, like an insurance company needs to address and be aware of and comply with 50 different potential conflicting areas, and they're all maybe considering AI a bit differently with what may be done there. So that's a challenge.
And do AI users have different skills from traditional HPC users, and does this impact service delivery and kind of supporting these users? Deepak, could you start us off, please?
Yeah, I believe so. I think that's a really interesting shift that we are seeing currently. If you look at traditional HPC users, they are mostly, physicists, engineers, chemists, mathematicians, are usually talking about, the MPI ranks, the parallel scaling, that's there for the HPC workloads. And these users, they are kind of familiar with compiling their code, the need for tuning the performance based on the hardware, and running the long simulation on hundreds of cores. Whereas this new community of AI users, they can be from any domain, any background, and the thing that they care about is the data set, and they should be able to run their notebooks, frameworks like PyTorch or TensorFlow, just like they run on cloud. So the I would say that the approach with which they are coming on our system is they want access to the compute as quickly as possible, and they want the access as seamlessly as well, just like they can spin up something in cloud. So for us at Cambridge, that's we have noticed that transition and this interesting shift that's going on, and we have changed our way in which we deliver and support our services, particularly related to the AI users. So we have had, we have to make HPC feel more accessible through web portals, like using web portal like Open on Demand, which enables the users to use their browser and submit the jobs on the HPC system without coming to the terminal, doing the SSH based access. We have also built a federation layer on the top of Dawn on system, which basically allows users to onboard quickly and securely. So as soon as we receive the request, they can use their own identities coming from different universities. They don't have to fill out those traditional HPC forms to be able to get the accounts on the system. So it really reduces the gap between requesting access and actually being able to run workload for these users.
Okay, so there's a bit of a difference, non-traditional users that don't necessarily have like a lot of HPC experience or using those type of systems, but still have the requirements for compute and large-scale storage. Mark, what are your thoughts on this topic? Have you seen any kind of difference in between these two types of users?
Yeah, there are. I think Deepak touched on it maybe without even saying it, but the notion of containers and having containerized workloads to allow a bit more portability amongst the different types of notebooks and other things is certainly much more prevalent in the AI world than in the traditional HPC space. They're also seeing the new skill sets are relative, and most AI is accelerated and using their GPUs, and so having traditionally run on CPUs, work has to be done to make them GPU friendly. So that's a different knowledge and skill set, and learning, for example, then with NVIDIA's CUDA software and in AMD's ROCm, how to you don't want multiple code sets. You want to try to make it as portable as possible. So that's a different, I think, a different skill set, and certainly a different mindset or approach when creating code and looking to move code and migrate code to adopt and integrate AI into additional workflows.
Andy, would you like to add anything to this?
Not very much, actually. It's a bit outside of the scope of Seagate, but what I will say is that using Seagate's experience, what in our own engineering and R&D departments, what we found is that there is a difference in use cases. We found that training and documentation help bridge the skills gap, and we've developed quite intuitive interfaces and APIs to improve accessibility to all the required users. So it's more of what I'd advocate is a high level of consciousness about the skills gap, rather than just assume that you, because you know HPC, you'll know AI by default. I think that, and that's what the other two speakers have already said, that it's about adapting the skills set that the users have to the.
Absolutely.
Yeah.
Okay, and I'm conscious of time. I think we can keep going. What about legal and regulatory factors? How do they impact storage and buying decisions? Andy, could you start us off on this one, please?
Yes, it's a question we often get asked when we're talking to people, and GDPR, SOC 23, HIPAA, all those things. What we always say to people is that just because someone has those standards or that compliancy, that's where you start, not where you finish it. You don't just tick the box and say, right, I'm done, because you keep on going and keep on improving and enhancing. Things like data sovereignty and auditability are becoming more and more important in storage, around storage. And we'd say that if you build legal requirements into the architecture from the ground up, you're going to be better placed than trying to bolt something on after you've got everything ready. Things like life cycle policies and automation can help an awful lot of the processes that organizations would need to adapt. And then finally, security and governance must align with all the frameworks. So it certainly is a big factor. It's something that we're talking about a lot with our customers, and we're being asked to fill out more and more convoluted questionnaires to be on the process.
Absolutely, yeah. And Mark, what are your thoughts on this?
Yeah, very similar. I'm not sure I have much to add. I was going to touch on the data sovereignty aspects, seems to be getting more critical, and ensuring data doesn't go somewhere it's not supposed to go, or that somebody doesn't want it to go to. And that's a balance then too, because there's some maybe data sovereignty requirements, but also balanced against you want to be able to collaborate with researchers globally and around the world. So some sort of balance of how to respect the data sovereignty aspects, but also get the most value out of the data by the collaboration. I already touched on some of the ones that's the compliance, like for the insurance company example. Yeah, I don't think I have anything more to add to this one.
Absolutely, that's fine. And Deepak, would you like to add anything?
Yeah, just from the university's point of view. In the university, we got data coming from the research data coming from different group. It could be from clinical department, which brings highly sensitive data, and so for those kind of things, the legal and regulatory factors play a huge role in how we make our storage decisions. We have had this service running within Cambridge called Secure Research Computing Platform, which which is kind of similar to what we normally know about trusted research environment, which basically provides an isolated platform to these research groups who come with sensitive data, and they don't want any hands apart from the people who have access to to that data sets. So when we look for technologies, when we decide to buy something, we look for systems that can enforce strong access control, encryption nowadays, and audit trails. And if they can have identity federation across multiple services, it's a plus. So this is how we look at this issue at Cambridge.
That makes sense. Yeah, I think that brings us to the end of our main discussion here. I would just like to thank all of our speakers for this informative discussion. We're now going to move over to our brief question and answer session. There's a couple of questions that have already come in from the audience. So, I mean, firstly, there's one here about interconnects. Specifically, kind of mentions the Spectrum Ethernet platform from NVIDIA, kind of competing with InfiniBand. Is this something? Do you have to account for interconnects and the change in technology there when you're looking at storage and kind of how does that play out? Deepak, could you take this one first, please?
Yes. Sorry, can you repeat the question?
Yeah. So kind of there's a discussion about interconnects between storage and looking at NVIDIA's offerings and InfiniBand and kind of how do you account for the changes in technology when you're planning out storage architectures and what are your thoughts on changing interconnect technologies?
Yeah, I mean it's like evolving with the workload, I would say, and I mean traditionally we are relying on the InfiniBand for our high performance workloads, including the Dawn system. But I think the question, which is kind of trying to explore, how Ethernet based alternatives are coming in as a part of the solution, is something which we are really looking forward to. Although this is something which need to be tested, for the workloads that we have. But yes, in terms of narrowing the performance gap, using Ethernet, because it's open, it gives you some cost flexibility, and it looks an attractive solution. So yes, we are actively looking at that thing.
Yeah, it seems like it's been specifically designed for AI, so maybe it's particularly applicable to Dawn and some of the stuff that you're doing with the Air research platform. Mark, what are your thoughts on this and Ethernet and it's kind of competing with InfiniBand?
Yeah, it's interesting. If you look at the top 500 list, and just look at the just the number of systems, are they what's the leading interconnect? And you go back a few years, it actually flip-flops over time, where Ethernet had been, most of the systems on the top 500 are Ethernet, and then InfiniBand kind of came on strong. And right now, I think of the total systems on the top 500, actually, I was looking at it recently. I was not just looking at the total one, but just looking specifically new entrants on the top 500 list. And most of the new entrants machines coming on for the first time, the last few years have been InfiniBand, have been more InfiniBand than Ethernet. But the very last one in June of this year, you see a more there was still more InfiniBand, but than Ethernet, but Ethernet was rising. So if that trend continues, there could be a flip in the system. Secondly, but if you look at the top systems on it, you see an awful lot of HPE-based systems coming in on the with the largest machines, exascale machines, and those are based on Slingshot, which is generally, when you're talking about InfiniBand and Ethernet, Slingshot is kind of accounted for in the Ethernet bucket. So if you look at that from a performance perspective, total flops on the top 500, especially on the top of the list, a lot of it's being run on Slingshot and more, if we consider that Ethernet. So they're there. It needs to be accounted for. They both occupy a large portion of the market. We've got a couple of other interconnects too that are making, that are appear in their niches. OmniPath is one. BXI is another that have their strengths in certain niches.
Okay, and Andy, would you like to add anything to this? I feel like maybe not, but it'd be remiss of me not to ask.
Yeah. What I would say is that with what Mark was saying was that it's a moving feast right now, and things do emerge and then disappear and come back again, depending on the mood of the public. What we're seeing is a disaggregated and composable infrastructure where things are compatible due to the APIs that are being developed, and so that means that you can pull together storage, compute, and memory via APIs, and therefore it becomes much more flexible. So it's I haven't really got an answer for you, really. It's as wide as it's long, really, I think.
I guess it's good to have multiple options out there, isn't it? At the very least, the competition is good for the larger ecosystem. Okay, there's another question here about fair principles for research data and how they apply to storage requirements. Or what is the best way to manage metadata, for example, or tagging? Should it be applied at the storage level or via a separate data management platform? Andy, could you take this one for us?
Should the metadata be stored separately? Is that what you're asking me?
Yeah, so just kind of how fair data principles apply to storage requirements, and yeah, specifically, do you think that this should be applied at a storage level or via a separate data management platform?
I don't know about fair data principle. Did you say it was?
Yes, yeah. So I can't remember what the I stands for. Fair, findable, accessible, reproducible, and something else.
Right.
Yeah.
Okay. Yeah. All right. So in our experience, metadata is vital. The robust storage of which is critical to the success of the product, because that's where most of the search gets done, and most of the bringing together data sets in new and innovative ways. That's because of the metadata. So we would say that it possibly warrants its own storage infrastructure. Absolutely.
Deepak, is this something that you've come across, in managing resources for Cambridge? What are the answer in your opinion?
Yeah, I don't know if I can answer the question fully, but what I can say, from our perspective in terms of providing these storage solutions to the user, the challenge is that the traditional file system, they don't natively understand, the FAIR concepts. When it comes to FAIR, principles, it is about the metadata richness, and things like who created the data, when it was created, how it was created, and with what are the different parameters associated with that. So this kind of information typically lives outside of the file system. So I think the other part of the question, which says how do you decouple the metadata and the policy layer from the storage. So yes, I agree with this. The metadata and the policy for the metadata should be separate from the file system as such, because the management of metadata and tracking of metadata should not influence what storage system you are using. So yeah, I mean, Andy, I think he touched upon in the previous question about the APIs. I guess here as well, metadata APIs, having extended attributes and namespace tagging is something which would be very, very useful to make sure the hybrid model works in our services.
And Mark, do you have anything you'd like to add to this topic?
Yeah, just a little bit. I think it's decoupled from the specific storage system itself. But if we think, I mentioned earlier, or the notion of a data platform, it's more than just a storage system that provides the actual physical data, but you up level the software that does the data orchestration and who like Deepak mentioned, who creates it, who has access to it. Is it interoperable? Which the I is interoperable and fair. I had time to Google that. Yeah, so I think answering the specific question, I think, is it part of the storage system or is it separate? I think it's part of the data orchestration aspects of a data platform, and whether that's where you consider that breakpoint between the actual storage system and the overall solution or data platform might be semantics.
Okay. And what can HPC providers do to support data management and sustainability specifically? How can we improve sustainability? And Andy, can you take this one for us?
Yeah. Okay. So with the growth of data and the growth of data centers, there is a very real risk that you may get more resistance than there is demand for AI data. So what's Seagate doing? I talk about how we manage it. We've got very high capacity drives, 30 terabytes with a route to 130 terabytes by the end of the decade. It takes the same power to spin a 16 terabyte as it does a 32 terabyte, just to give you a little nugget of information there. So what we're saying there is that by going to that level of capacity, you are halving your watts per terabyte. And also halving your space as well, because you're storing double the capacity in the same amount of space. So those are just two areas that we work in, and the third area is that I think Seagate's got 2,500 vendors. 60% of all our purchase come from just 10 of them, and we work with those 10 very extensively on making sure that the whole supply chain is up to speed and on environmental with an environmental strategy, so that we can conform to all the government regulations and requirements. So for Seagate, it's very important. And then the whole of life cycle after the product is let's say it's 5 years, it's finished, it's life. How do we then manage that? And we've got a lot of our products that is being recycled or regenerated and reissued as warranty replacements, for example. So there's lots of different things going on with Seagate.
Absolutely. Mark, have you anything you'd like to add to this?
No, I think it's everything that Andy said there. One thing, and just interesting point though, you look at a spinning disk drive, it's what, roughly, Andy, correct me if I'm wrong, it's what, around 15, maybe 15 watts for when it's operating, an average power consumption of a disk drive. And then compare that to what the power draw or an energy requirement is for a GPU, which is approaching a kilowatt per GPU. So from a power consumption perspective, just the power consumption aspect of sustainability, it's the disk drives are kind of a drop in the bucket. Doesn't mean you should ignore it or not pay attention to the power consumption of the storage, but it kind of pales in comparison to the compute aspect of the solutions.
Yes, certainly there are better savings to be made in different parts of the hardware stack, potentially. And Deepak, do you have any additional anything you'd like to add?
Yeah, just I think the awareness about the data into the infrastructure. We talked about the life cycle of the data, moving from the performance tier to the inactive tier, and then to the tape libraries. So currently we are doing these by custom built solutions. If we can have all these solutions, capabilities native within these storage systems is something I think which would be very useful. for the whole data lifecycle. Like things like if the data can be automatically classified based on the age, uses, and the performance, and can be moved across intelligently, different tiers is something that would be very good.
And just one final question's come in from the audience, so I'm going to squeeze that one in. Going back to tiered storage discussion, are hierarchical storage managers, HSMs, still used, or have newer interfaces become preferred? Deepak, I guess this is probably you're a good place to start here.
Sorry, I didn't understand the question.
So hierarchical storage managers, HSMs, are they the kind of what's used for tiered storage, or are different interfaces being used today?
If I'm understanding the context, I think the traditional HSM model, automating the data migration between disk and tape was great in theory, but it's often too rigid for scaling and the kind of diversity we have coming in the data for our users. So I think for us is more of a policy driven model where we give this freedom to project managers to decide what data stays active, where it gets archived, and when they want it to be archived. Behind the scenes, of course, there's automation, but our idea is to give them more transparency and control in their hand only.
So it's freedom within the policies that are created by the organization. Okay. Andy, would you have anything you'd like to add to this?
I can't talk about HSMs specifically. What I can tell you is that within sort of native within our enclosures, we have auto tiering, so you can have a mixture of SSD and spinning disk within the enclosure, and as soon as data is in use, it's promoted to the SSD, so you get the fastest arch performance, and that's just a function of the software of the management software of the enclosure itself. When you look at our cloud options, we auto tier down, so if the object hasn't changed after a fixed period fixed by the user, then it would migrate down to the lower tier, the lower price tier for archive purposes. Managing data out of that infrastructure onto tape, I think that would be a separate piece of software or HSM, but the truth is I don't know much about them, so I'm not going to comment about Seagate.
And just on that, the auto tiering you just mentioned there, can users have some control over that policy? The amount of time before a piece of data gets moved up or down a storage tier?
Well, you can pin data sets to the SSD, so you say, right, that's always going to be held on the flash, but the promotion from disk to SSD is instantaneous, just as soon as it's available. So you couldn't use the whole capacity to pin all your data, because then you wouldn't get any space to move it up. But just because we design our own ASICs that control these things, we get the instantaneous promotion of data to the SSD tier.
Okay, thank you. And Mark, is there anything you'd like to add before I close this off?
I think just kind of what Deepak said, as far as maybe what was the original definition of what HSM is and was, has as it was originally defined, isn't maybe as adopted or applicable as data has changed and the storage requirements and systems have evolved. So more things with the notion of data orchestration, I think, has evolved and maybe replaced some of what was traditionally HSM in getting the data where it is. So yeah, nothing too much more to add.
Great. Well, thank you. And that's going to bring us to the end of today's webcast. The content will remain on Scientific Computing World website at www.scientific-computing.com for the next 12 months. So please spread your word if you've enjoyed this presentation. Of course, please note that live question and answer will not be functioning if you're listening on demand. Once again, thanks very much to our speakers, Andy, Deepak and Mark, and of course, thank you to our sponsor, Seagate. Thank you all for listening.
Thank you.
Yeah, thank you.
Cheers, everyone, and
Bye-bye.
goodbye.